last lessons, we learned about atomic size of an atom. But most importantly, we learned how to use the periodic table to determine the relative size of different elements on the periodic table. And we realized that the trend for atomic size is basically going from left to right. We noticed that the atomic size decreased. And we also learned that going down from top to bottom on a periodic table, atomic sizes increase. Now we are going to look at the sizes of atoms to determine other trends. Well, in this case, we are going to look at something called electronegativity. And that's how you say electronegativity. Well, what is electronegativity? It is the measure of an atom ability. That means, what is that atom ability to do what? Well, think about negativity. What is negative? Electron. So it is to attract the negative electron toward itself. Remember, electrons are negative. So electronegativity is the ability of an atom to attract electron, basically gaining that electron from another atom. And of course, we know that all the elements over here, we remember that this right here and this right here, they love to gain electron just to be stable. Where on this side, we remember that what do they want to do to be stable? Well, they want to lose their outermost electrons. So keep that in mind. Now, if we just look at these two basic facts, if we look at this side want to lose electron and this side want to gain electron. So which of the two will have a higher electronegativity? Of course, the one with the higher abilities of wanting to gain electron will be higher electronegativity. So over here, you would have higher electronegativity. And we are going to abbreviate electronegativity with En, okay? So that's the abbreviation for it. Now let's look at the trend for electronegativity. What we notice is that all the atoms over here are very small compared to this side. Okay, so in a smaller atoms, you need to imagine in a smaller atoms, inside here we have a positive proton. And from that positive going outside, we have our radius, right? But surrounding here are a bunch of electrons from another atoms. You have to imagine that. So in a smaller atom, the nucleus, the positive nucleus, is closer to the valence electron of nearby electrons. So in a smaller atom, a positive nucleus, which is right here, is closer to the valence electron of nearby atoms. That makes sense, because if we look at this larger atom, the distance from the nucleus to the outside electron is a lot farther compared to the smaller atoms. So right away, we have to realize that in a smaller atom, you would have a higher ability for this proton or that nucleus to gain electron or steal electron from another atoms. So that's one fact that we have to remember. Smaller atoms have higher electronegativities. And of course, En is electronegativity. So if we notice, looking at the periodic table, going from left to right across a period, going from here to there. So if we look at the trend of electronegativity on a periodic table, it is the opposite of atomic size. Going from left to right across a period, electronegativity increase. So going this way, electronegativity increases. And why is that? Well, that's because the atomic size decreases. Remember, smaller atoms have the ability to gain electron from nearby atoms. Now, what about in a larger atom? Of course, in a larger atom, we looked at this before, it is too far away for this proton or that nucleus to gain the electron from all the way outside, right here. It's too far. So, of course, it has a lower electronegativity. In this case, in a large atom, the nucleus is farther away from the electron of nearby atoms. So it would be more difficult or it'd be harder for it to attract nearby electrons. So therefore, if we look at back here on the periodic table, looking at the trend going down, it has the opposite trend of atomic size, just like we have here, because the atomic size is getting larger. So in this case, En, which is electronegativity, would decrease. Because why? Because the size of an atom actually increase. So keep that in mind. So for this task, we are going to rearrange the following set of atoms from highest to lowest electronegativity. Here I have B and F. So B is right there, N is right there, F is right there. I circle it so that way I know where they are on the periodic table. And if we notice, we are looking from the highest to the lowest. And we remember that's increasing this way. So the highest will be all the way over here. Of course, it's going to be F, right? That would be the highest. Followed by what? It will be N. And lastly, followed by B, which is boron. So that's how you do it. You have to find where they are on the periodic table. Let's try another set. We have sodium, potassium, and lithium. So find where they are, sodium, potassium, and lithium. And if you notice, we're looking for the highest first, right? And we know that the trend is decreased as it's going down. So as it goes down, it will be the lowest. So we wouldn't want to look for the one all the way to the bottom. We're going to look for the one on the top, which is lithium. So lithium would be the highest, because going down it decreases, followed by what? Well, sodium, and lastly, potassium. Let's try another practice problem. Rearrange the following set of atoms from the lowest to highest. So I twist it the other way around. Let's find them. Well, in this case, we have nitrogen. In this case, we have nitrogen, lithium, and boron. Here we have nitrogen, boron, and lithium. And we know that we're looking from the lowest to the highest. So the trend is En increased. I mean, it gets larger and larger going this way. So the lowest one would be all the way over here, isn't it? So therefore, it has to be lithium, which is all the way over here, followed by what? So lithium is the smallest, followed by boron, and lastly, we have nitrogen. And it makes sense. Nitrogen is, in group 5A, it would want to gain electrons, so therefore it's very electronegative. Let's try another one. We have calcium, beryllium, and magnesium. So we have calcium, magnesium, and beryllium right there. And we want the lowest to be first. So again, going down, in this case, is decreased. So the one with the lowest would be the one on the bottom. Calcium, followed by magnesium, and followed by beryllium. So be careful when you apply this rule. Find where they are on the periodic table and use your understanding in terms of what happened if we go across. Is it increase or decrease? The same thing, what happened when we go down? Is it increase or decrease? And that's how you apply the periodic trend of electronegativity.